Hello, welcome back. Today we're going to do another LeetCode problem of union find. Today's problem is 2316. Count unreachable pairs of nodes in an undirected graph. We're given an undirected graph with n nodes, numbers from 0 to n minus 1. We're also given a set of edges of this graph in the form of a 2D integer array. And our job is to return the number of pairs of nodes that are unreachable from each other. Let's take a look at an example of this. We have a graph with 3 separate components. Pairs of nodes from different components are unreachable from each other. So for this example, 0, 3 would be unreachable pair, also 0, 4, also 3, 5, etc. There are a total of 11 unreachable pairs for this graph. For this problem, we're going to deploy union find. We're going to find the different components, and we're going to find all pairs of nodes in which one of the pair is from one component and the other of the pair is from a different component. So let's take a look at the code. These C# codes are provided in the GitHub links below. To start off, we're going to put some boilerplate codes from union find. Again, we have the find parents function and also the union function. All this was discussed in the first video of the series. I left the links to that video below in the description. Please watch that video if you have not done so already before continue with this one. We initialize the parent array with the size of n, where n is the size of nodes in the graph. And we use a for loop to initialize the parent array such that every node is a parent of itself. Then I use a for each loop where I iterate all the edges and calling the union operation for both nodes of that edge. After the for each loop is done, the parent array would have these values. Next, using the parent array, I will find all the separate components. For each component, I will find the parents of that component and how many vertices are in each component. And this information I will store in a hash map. And in C#, a hash map is a dictionary. So I make the dictionary groups, and then I iterate the parent array. For each vertex, I will recursively find the parent of that vertex. And then I will update the number of vertices in the group with the same parent by 1. After this step is done, we can see for this example, the value of this hash map is here. As you can see, there are a total of 3 separate groups. The first group, the parent is 2, and there are 3 members. The second group, the parent is 4, and there are 2 vertices in that group. And the third group, it is just the node number 5. Next, we will count all pairs of nodes that are unreachable from each other. Unreachable pairs are such that one of the pairs is from one component and the other pair is from a different component. And we want only unique pairs. So we go through every group and then we take the group size, so the number of vertices in that group times the number of vertices outside of that group. So in this example, say we take the group where the parent is 2, and then there are 3 vertices, and there are also 3 vertices outside. So 3 times 3, that is 9. So that is the first iteration, and we add that value to the count. In the next iteration, we take the next group where the parent is 4. There are 2 vertices in that group, and then we take 2 times nodes that are outside of that group. But here, we don't want to count the first group because we don't want to double count. So we only take 2 times a number of vertices that are outside of that group, not including the first group. So it's 2 times 1. So in the second iteration, we have 2. In the third iteration, we take out the groups that has been counted. And then all we have is the node number 5, and you cannot make a pair from that. So the count is 0 in that iteration. So we have first iteration, 3 times 3, 9. Second iteration, 2 times 1 is 2. And then it's a total of 11 pairs. And that's the value we will return. Now we will test whether this works. And it looks good. Okay, like other videos, I have also included the weighted version of union find for this question. Again, the only modification here is I introduced the rank array. And also, I modified the union function. I discussed in detail the weighted version of union find in the first video of this series. If you have not watched that video, please go there and take a look at the discussion on this version of union find. I have the links to that video in the description below. Okay, let's test this one too. And it's good. That's it for today. Hope this is helpful. See you next time.